2, 1. All right, so today we're going to finish developing the unit circle, and we'll go over the test tomorrow, okay? Cosine of 210, cosine of 210. So here's what you want to think to yourself. Cosine, first of all, is the x or the y value? It's the x value. So at 210, I'm not going to peek down to my diagram. I'm going to say, where in the heck is 210? Well, it's 30 degrees past 180, right? It's 30 degrees past 180. So I know that the reference angle is 30 degrees. And anytime the reference angle is 30 degrees, I know that the ordered pair is some type of square root of 3/2, some type of 1/2. Yeah. And because I'm in quadrant 3, to get there, I have to go left and down. So I know they're both negative. So that's the ordered pair at 210. Here's the x and here's the y. So here's the cosine and here's the sine. So what is cosine of 210? Negative square root of 3/2. Kaboom. So that's how we're going to do it in the future. Now you can look down here and you could also say, here's 210 degrees. Cosine is the x coordinate. That's what we developed last time. Okay. Yeah. It's the same as the cosine of 150 because those are the two angles with the 30-degree reference angle to the left of the y-axis. Okay. So for this one, sine of 330, you're going to be like, oh, where does 330 live? He's over here. He's 30 degrees short of a full rotation. So again, it's another triangle that has a reference angle of 30 degrees. So I know the ordered pair is some type of square root of 3/2, some type of 1/2. And how do we get there? We have to go right and down. Right and down means it's positive, negative. Yes, yes. And so sine of 330, sine y, right. So the y value there is negative 1/2. So that's the ratio. There you go. And just for kicks and giggles, what would the cosecant of 330 degrees be? What would be the cosecant of 330 degrees? -2, right? -2/1. Because how are sine and cosecant related? Reciprocals. Yeah, yeah. If we did the same thing over here, what's the reciprocal of cosine? Secant. So what would secant of 210 degrees be? Yeah, you would flip that and get -2 over the square root of 3. But when we re-rationalize it, you get -2 square root of 3/3. Okay. Don't this fun? It do. Yeah, very good. All right. And we've only talked about our 30-degree reference angles. We still got the 45-degree reference angles. We still got the 60-degree reference angles. And we still got the quadrantal angles that fall on the x-axis.
45-degree angles, everything's just the same. All the r's are the same, or the x's and y's are the same.
Wait, are you saying that the r's and the x's and the y's are all the same to each other?
No, the r's are the same to other r's, and the x's and y's are the same to other x's and y's. What?
Okay. Yeah, you're right. For a 45-degree, it's an isosceles right triangle. So the x and y are the same to each other. Okay. They're both square root of 2/2. We've already done that. And the radius is still the same. It's 1. Yeah, that's what you mean. Okay, good. Yeah. So we can take that and go with it. So speaking of 45s, let's go ahead and do that. 45. I need to move this over. I'm kind of encroaching on my warm up here. So look at that. We were here first. The warm up came in, and now I'm retreating. That's like Russia invading Ukraine. Ukraine was already there. And then Ukraine leaving? No, we stay and fight. I'm leaving that there. Warm up, you leave. You leave, warm up. Just beat it. Ooh, just beat it. Beat it. So that's tomorrow. So you have time to practice your flash mob skills tonight. What the heck? I messed it up, man. That is like, it's almost total annihilation. There we go. I'll move it up there. Yeah, you go back to your country. All right, thank you. All right, beat it. Beat it. Ooh. Yeah, you got, if you walk on your hands all day. Yeah, there you go. But it is, yeah, supporting upside down Ukraine. I like it. All right, so first of all, let's look for a flavor. What flavor do you want to use for the 45s? For me, orange. Okay, we'll use orange. All right, purple and orange. We'll go with like the Clemson Tiger colors. All right, so remember your 45. We did that over here. We scaled the hypotenuse to 1, and the two side lengths were square root of 2/2, square root of 2/2. So to draw the 45s, there's 4 of them. let's go ahead and do it as such. I'll make a thicker line quality, draw a line from one side to the other through the origin like that. And then kind of the same going the other direction through the origin, something like that. I don't like that second one I drew. You want to kind of come in at a 45, right? Yeah, that looks better. No, I don't think the first one's too hot either. Yeah, I like that one. That one looks good. Again, we're just eyeballing this, right? We're coming in at a 45. So
Snap, I think it will snap in at a 45. Like if you rotate it,
really,
yeah, I think
it'll
will.
stop at 45 degrees.
Yeah,
Just for fun.
it stops at 45 degrees, but if it's like guiding along another object, like the edge of the circle, it doesn't.
Oh, okay. Well, I'm just gonna leave it like that, right? Okay. That's like Ukrainians like war symbol right now, right? Like beat it, just beat it, just beat it. Okay. Now let's drop a perp here to create two triangles and drop a perp here to create two. Actually, look, if we do this, if we drop a perp through here all the way through, you get the symbol for the dead Kennedys. DK. This yeah, D. Yeah, oh, there you go, Daniel Kelsey. This is D and K in a circle. If you put DK in a circle, this was the logo for the punk band Dead Kennedys back in the day. So just FYI, this, like back in the day, we would like graffiti our shoes and our skateboards with this symbol, right? We're like, punk is cool. So anyway, a little bit of cultural literacy there. But anyway, I'm not advocating deceased Kennedys. They were a great family, and unfortunately, a lot of them were assassinated. It's not very friendly discussion. Okay, so now I have my four triangles. So let's go around the horn here and label it. This right here is what angle? How do I rotate to get there? It's your 45-degree angle, yes? And the reference angle is 45. Now, what's the ordered pair there? Well, we look back over here. I got to go right, square root of 2 halves, and up square root of 2 halves. So the ordered pair is square root of 2 over 2, square root of 2 over 2. Okay? So what would the cosine of 45 degrees be? Square root of 2 over 2. What would the sine of 45 degrees be? Square root of 2 over 2. Yeah. What would the tangent of 45 degrees be? 1. Because tangent's y over x, right? And anything divided by itself is 1. Yeah. What would the cotangent of 45 degrees be? Also 1, because x divided by y divided, yeah, nice.
Split, but it's the same thing.
Yeah, so I think that's what Brady was getting excited about, and I get excited about it too. 45s are pretty easy. Now, just for kicks and giggles, since we're right here, what would the secant of 45 degrees be?
Wouldn't that just be 2 over square root of 2?
Yeah, you flip it, 2 over the square root of 2. But when you rationalize that, you get 2 square root of 2 over 2. And what happens with the 2's now? They divide out. So, yes. So, keep this in mind. The reciprocal of the square root of 2 over 2 is just the square root of 2, right? And what's the reciprocal of the square root of 2? Rationalized? The square root of 2 over 2. That's going to show up quite a bit. Okay, so let's say that again. What is the reciprocal of the square root of 2 over 2? The square root of 2. That's worth memorizing. And what's the reciprocal of the square root of 2? Square root of 2 over 2. That's after we rationalize it. Okay, so what would the cosecant of 45 degrees be? Good. The cosecant of 45 degrees is also the square root of 2. That's the reciprocal of the y value, which is the same. Okay. Everyone good with that? All right, so now we can pick up the pace a little bit. What would the angle be over here? Well, let's do the ordered pair first. The ordered pair, since it's a 45-degree reference angle, is going to be some type of square root of 2 over 2, some type of square root of 2 over 2. And all you got to do is figure out, okay, to get to that point, I go left and up. Left and up is negative, positive. Yes, yes? So that's the ordered pair. What's the angle that gets me there if I stop 45 degrees short of 180 degrees? right? This reference angle down here is 45. So I got to stop 45 degrees short of 180. What's 180 minus 45? 135. Good. 135. Man, 5, you are so dirty. Whew. That is 135. Y'all are much more mature than I am. No one laughed at that except me. Yeah, I mean, poop jokes, right? Yeah. They don't, deserve to be acknowledged, especially by a 48-year-old who's in charge of kids, right? Okay, with my eyes closed, watch, I'll make it up to you. What is the cosine of 135 degrees? Negative square root of 2 over 2. What is the sine of 135 degrees? Square root of 2 over 2. Yeah, cool. What is the tangent of 135 degrees? -1. Because what's a positive divided by a negative? Negative. Okay, what is the cotangent of 135? That's x over y, right? It's still -1. Yeah. All right. What would be the cosecant of 135? The cosecant of 135 is the reciprocal of the sine, which is the y value. What's the reciprocal of the square root of 2 over 2? Square root of 2. High five. We memorized that. We don't want to have to flip and re-rationalize it. Good morning. Okay, and then last one. What is the secant of 135? -2 square root of 2 over 2. And then the 2's divide out, right? So what's the reciprocal of the square root of 2 over 2? It's just the square root of 2. Yeah. So let me just write that down because that's important. Secant of 135 degrees. We're going to quiz over this soon enough. And I'm going to give you like probably 20 seconds to come up with these answers. You know you're going to flip negative square root of 2 over 2. So if you go -2 over the square root of 2, I want you to rationalize that. So if you say -2 square root of 2 over 2 because you're rationalizing in your head, that's not wrong, but it's also not simplified. And a lot of students, when they rationalize it, because you don't always get to divide out things when you rationalize, but in this case you do, and it's just negative square root of 2. So that's the answer that I'm going to require when we start quizzing over this. I'm not going to accept -2 over the square root of 2. I'm not going to accept -2 square root of 2 over 2. When I ask you what secant of 135, I want you to say negative square root of 2. And what is the cosecant of 135? Positive square root of 2. Got it? Okay. Square root of 2 over 2 and the square root of 2 are reciprocals of each other. Let's write that down. If it's so important, let's write it down. The square root of 2 and the square root of 2 over 2 are reciprocals of each other. And then we'll put in here simplified. Get used to that, okay? It's a time saver. Now, if I ask you what's the reciprocal of square root of 3 over 2, when you flip that and rationalize it, you get 2 square root of 3 over 3. The 2 and the 3 don't divide out, right? Square root of 3 over 2 and 2 square root of 3 over 3 are reciprocals. But you can do that in your head probably, right? The 2 and the 3 here, they don't divide out like they do for the square root of 2. Everyone good with that? Okay. All right, so that's 135. Oh, my leg is stuck. Okay, got it. All right, let's rotate over to this point. We're 45 degrees past 180. And because it's a 45-degree reference angle, we know it's some type of square root of 2 halves, square root of 2 halves. How do we get there? In quadrant 3, we go left and down, left and down. That's negative, negative. Yes, yes? So that's the cosine and sine respectively. And what angle puts us there? If I rotate 45 degrees past 180. 180 plus 45, 225 degrees. All right, so here's how we use it. We'll go through all 6. What is cosine of 225 degrees? Negative. Complete your thought. No. Cosine of 225 degrees. Negative square root of 2 over 2. Yeah, or negative square root of 2 halves. I don't care how you say it. Negative square root of 2 over 2. Negative square root of 2 halves. Boom. What is sine of 225 degrees? Negative square root of 2 halves also, okay? What is tangent of 225? Positive 1. What is cotangent of 225? Positive 1. Yay. What is the secant of 225? No. Negative square root of 2. And what's cosecant of 225? Also negative square root of 2. Boom, we get all 6 trig functions from one simple ordered pair. We get all 6. Just beat it. Just beat it, beat it. Just beat it. Ooh, beat it, beat it. Ooh. All right, one more to go. If we rotate over here into quadrant 4, that's your 45-degree reference angle. You know the ordered pair is some type of square root of 2 halves, comma some type of square root of 2 halves, right? And how do we get there? We go right and down, right and down. That is positive, negative. Boom, there's your ordered pair. Now let's figure out what angle that is. I'm stopping now 45 degrees short of 360. So what's 360 minus 45? 315 degrees. Oh, and you know what's coming next? All 6 trig functions. What's cosine of 315 degrees? Square root of 2 halves. What is sine of 315? Negative square root of 2 halves. What is tangent of 315? Negative 1. What's cotangent? Negative 1. What is the secant of 315? Ah! No, secant is of 315 is positive square root of 2. Because secant is the reciprocal of cosine. Cosine is x, and in quadrant 4, x is positive. So cosine and secant are positive. So one more time, what's secant of 315 degrees? Positive square root of 2, or just square root of 2, right? And what is the cosecant of 315? Negative square root of 2. All right. Hey, and it's only 9:15, and we just did 315 at 9:15. Coincidence? Totally, dude. All right. Now we've got we got our 60 degrees. 60 degrees. Okay, so I'm going to choose aquamarine. Okay, aquamarine. For our 60 degrees, we're going to have to draw something like this all the way across. Snap, and then similarly like this ish, right? And then we drop a perp, and we drop a perp. Okay, so now we have our 60-degree reference angles. 60-degree reference angles. Well, let's come over here. Let's reorient the 30, 60, 90 so that 60 is the base angle. Okay, so if I do that, whoa, okay. Here's 60 degrees now. Wait, I need to chill my writing out here. There we go. If that's 60 now, and this is 30, and this is your 90, which is opposite 60? Square root of 3 halves, right? Which is opposite 30? 1/2. Okay, so it's the exact same triangle. We're just orienting it differently. Okay, yeah. Because we've rotated up closer to the y-axis now, our triangle is taller than it is wide. Yes, yes? Taller than it is wide. So the x coordinate is the smaller of the two. It's 1/2, and the height is the larger of the two, square root of 3/2. This is where students kind of get confused because it's the same numbers, but the ordered pair is flipped, okay? So let's go ahead and write the ordered pair right here. The ordered pair to get there is going to be some type of 1/2, some type of square root of 3 halves. And of course, because we're in quadrant 1, it's right up, so that's positive, positive. You don't have to put plus signs in front, but I'm doing it sometimes for tax clarity. Thank you. God, I need to take more ginkgo biloba. All right. Now, what is the angle that gets us there? 60, right? In quadrant 1, it's just 60 degrees. Good. So here we go. You know what's coming. What is cosine of 60? 1/2. What is cosine of 30? Square root of 3/2. Ah, see? When I'm at 30, now I'm wider than I am tall. So the cosine is the square root of 3 halves. But when I'm up at 60, the cosine is smaller because the x is smaller to 1/2. What is the sine of 60 degrees? Square root of 3/2. What is the sine of 30 degrees? 1/2. See that? Good. Okay. What is the secant of 60 degrees? 2. What is the cosecant of 60 degrees? Flip the square root of 3 over 2. 2 square root of 3 over 3. Right. Yeah, 2 square root of 3 over 3. That's probably worth memorizing as well. The reciprocal of square root of 3 over 2, when you rationalize it, is 2 square root of 3 over 3. These numbers are going to show up often. All right. Now, because the x and y are not the same, the tangent and cotangent are a little bit more interesting. Let's write that out. What would the tangent of 60 degrees be? Well, that's y over x. Look what happens. When I take the square root of 3 over 2 and I divide it by the x, which is 1 over 2, if I do stay, change, flip, stay, bad Russia, times 2 over 1, the 2's divide out, and I'm just left with the square root of 3 over 1, right? Square root of 3 over 1, which is the square root of 3. So here's what's cool. When you're doing the tangent or the cotangent, you don't have to worry about the 2's. This is why we rationalized our denominators, so that the denominators can be the same. The 2's will always divide out. So when I ask you for tangent of 60, all you have to do is say, oh, it's going to be the y value of the numerator divided by the x value of the numerator, because the 2's are going to divide out. So what is tangent of 60 degrees? Square root of 3 over 1, which is what? Square root of 3. What would cotangent of 60 degrees be? 1 over the square root of 3. When we rationalize it, is what? Square root of 3 over 3. Let's write that one up here too. The square root of 3 and the square root of 3 over 3 are reciprocals of each other. Now, you don't have to memorize. You could actually flip it off to the side on your workbench, rationalize it, and then if it simplifies, divide things out. Nothing divides out here, okay? So let's come back down here and do that again. What would be the tangent of 60 degrees? Square root of 3. Good. What would the cotangent of 60 degrees be? Square root of 3 over 3. What was that, Brady? Cotangent. Yeah. Cotangent would be 1 over the square root of 3, which when we rationalize is square root of 3 over 3. The 2's divide out. You don't have to worry about it. Right? Awesome. Hey, look, does that work for 30 degrees as well? 30 degrees? There I am again. What would be the cotangent of 30 degrees? Square root of 3, x over y. The 2's divide out. Good. What would the tangent of 30 degrees be? Square root of 3 over 3. Kaboom, right? Oh, this is so much fun. That was the beginning of the Mexican hat dance. I don't know why that song just jumped in my head. Okay. Y'all are so tolerant. I appreciate that. All right, let's look in quadrant 2. If it's a 60-degree reference angle, I know the ordered pair is some type of 1/2, some type of square root of 3/2. Again, why does the 1/2 come first for a 60-degree reference triangle? It's taller than it is wide, or it's narrower than it is tall, right? And now because we're in quadrant 2, that's left and up, so it's negative positive. What is the angle that gets us there from the positive x-axis if we stop 60 degrees short of 180? 120. Good, good. So what is the cosine of 120? Negative 1/2. What is the secant of 120? Negative 2. Very good. What is the sine of 120? Square root of 3 over 2. What is the cosecant of 120? 2 square root of 3 over 3. Flip it, rationalize it. What's the cosecant of 120? 2 square root of 3 over 3. Bam. And now these are easy as well. What is the tangent of 120? Tangent of 120. It's not just the square root of 3. The 2's divide out, but you do have to worry about the sign. It's just the y value divided by the y value, but you do have to use the signs. So what would the square root of 3 divided by negative 1 be? Negative square root of 3. Yeah. It's only the 2's that divide out. So be careful with the signs. So what is the tangent of 120? Negative square root of 3. And what would the cotangent of 120 be? Negative square root of 3 over 3, right? Boom. We got them. We got them all. Let's rotate into quadrant 3. If it's a 60-degree reference angle, the ordered pair again is going to be some type of 1/2, some type of square root of 3/2. And now you're like, hey, I'm in quadrant 3. To get to that point on the circle, I go left and down. So now like both of my friends, they're both negative. I've been looking for new friends for a while. They're both negative. What is the angle that gets us there if we go 60 degrees now past 180? 240, right? Oh, I can't eat Taco Bell anymore. No, why not? Because it makes me 240. Golly, what's up with the poop jokes? That was a fart joke. Yeah. Because I'm not eating Taco Bell, I'm avoiding the poop joke, right? I'm saying, oh, no, makes me 240. Yeah, my dad would be so proud. Yeah. The only comment my dad ever had on my sense of humor was one time he got mad. He goes, "You have a stale sense of humor." It's like, wow, thanks, Dad. I won't even tell you the joke that I told him. But after that, I was like, man, you don't appreciate a good zinger, Dad. I'm not going to tell you anymore. So anyway, what is cosine of 240? -1/2. What is the secant of 240? -2. What is the sine of 240? -3/3/2. What is the cosecant of 240? -2 square root of 3/3. Good. What is the tangent of 240? Positive square root of 3. Because negative square root of 3 divided by -1. Good. What is the cotangent of 240? Positive square root of 3/3. Okay. And every time that I said 240, I was thinking, can't you? No. It'll make, 240. I have other people in mind, you know. Last one. This is being recorded, by the way. Oh, man. Posterity. Right. When I get fired, they'll play this back and say, that's why. He was teaching the kids about flatulence. All right, I'm at a 60-degree reference angle in quadrant 4. Because it's a 60-degree reference angle, I know it's some type of 1/2, some type of square root of 3/2. It's got to be. And because I'm in quadrant 4, I got to go right and down. That's positive, negative. Boom. Now the angle. If I stop 60 degrees short of 360, what's the angle? 300. Okay. What is the cosine of 300? 1/2. What is the sine of 300? -square root of 3/2. What is the cotangent of 300? Yeah, negative square root of 3/3. I'm asking them in a different order now, right? What is the secant of 300? 2. Good. What is the tangent of 300? Negative square root of 3. And one of my favorite questions, what is the cosecant of 300 degrees? I ask my waiters and waitresses all the time. Yeah, can you bring some more tea? And yeah, what is the tangent? Or the cotangent, sorry. What is the secant? Sorry, what did I say? The cosecant. What is the cosecant of 300 degrees? What is the cosecant of 300 degrees? -2 square root of 3/3. Boom. Yeah. And if the waiter gets that right, I give him a huge tip. And if the waiter gets it wrong, I give him a huge tip. Yeah, just because I'm a big tipper, right? I'm a big tipper. I give him a big tip, and then one tip also on the side as I'm walking out. Hey, you might want to go learn your unit circle. Just another tip on the way out the door. Yeah, different kind of tip. I think waiters and waitresses probably like tips in the form of like currency, right? Instead of like advice, right? I always leave a 20% advice, on the bill. So much fun. So there you go. That takes care of all the interior angles. Guess what angles we have left? Not exterior angles, but the angles where nothing happens. Okay. Nothing happens. So I'm going to choose Greece for this. Okay. Greece right here. The quadrantal angles. If you look at 0 degrees, which is coterminal with 360 degrees, what happens to the triangle? Imagine going from 90 degrees and rotating all the way down. What's happened to the height of the triangle? It goes from square root of 3/2, square root of 2/2, 1/2. And then when I hit the x-axis, the height goes to what? 0. We've collapsed the triangle down to nothing. Okay. So guess what the ordered pair is there? I'm on the unit circle. So to get to the right, I just go straight to the right, 1 unit. And how high do I go up? Not at all. Very good. So there's the ordered pair at 0 degrees and 360 degrees. Same ordered pair. What would the cosine then of 0 degrees be? 1, right? That's when the hypotenuse is at its absolute maximum of 1. But to reach a hypotenuse of a maximum value of 1, it comes at the cost of the other dimension being non-existent. So what's the sine of 0 degrees? 0. And that's easy to remember because remember, it's not just sine y, it's sine y height. And if you're on the x-axis, you crust your triangle down vertically to a height of 0. There you go. Triangle abuse, maybe. All right. So what would the secant of 0 degrees be? Wait. I'll wait. What? Wait. It's the reciprocal of 1, yeah? What's the reciprocal of 1? 1. Yeah. So what's cosine of 0 degrees? 1. Cosine is x. What's the cosine of 360 degrees? 1. Good. What is cosine of 0 degrees? 1. What is secant of 0 degrees? 1. What is secant of 360 degrees? 1. Y'all know any number besides 1? What? 0. Yeah, 0, which means no, we don't. Funnily enough. Okay, what would the sine of 0 degrees be? 0. What is the sine of 360 degrees? 0. What would the tangent of 0 degrees be? It's y over x. What's 0 divided by 1? 0. 0 divided by 1 is 0. Yeah. So what's tangent of 0 degrees? 0. What is tangent of 360 degrees? 0. Okay. Now for the other ones. What is the cotangent of 0 degrees? That's 1 over 0. 1 over 0 is division by 0. It's dne. It's some type of infinity. There's a what on the graph there? A vertical asymptote. You can't divide by 0. Okay. Can't divide by 0. Error. Yeah. So what's the cotangent of 0? dne. What's the cotangent of 360? dne. Does not exist. You can put dne. Yeah. All right. And then we have this. What is the cosecant of 0 degrees? Well, cosecant would flip the y value, right? What's the reciprocal of 0? Well, let's see. Here's 0, which is equal to 0 over 1, right? You can write it as 0 over 1. Is that okay? We just said that up here, right? Still true. So now I have something to flip. If I flip it, I get 1 over 0, which is what? dne. So what's the reciprocal of 0? Does not exist. And it's because it's some type of infinity. So really, what's the reciprocal of 0? Some type of infinity. Very good. Infinity. What's the reciprocal of infinity? 0. And what's the reciprocal of 0? Infinity. But what's the reciprocal of infinity? 0. And 0's reciprocal is what? Infinity. Now, when we quiz over this, don't put infinity because I don't know if it's positive infinity or negative infinity. It could be one of each. So we just put dne. But the reason it doesn't exist is because it's some type of infinity. Okay. So what is cosecant of 0? Doesn't exist. Anytime you flip 0 or you have a 0 in the denominator, you're going to get dne. So again, what is cotangent of 0? dne. What is cosecant of 0? dne. Those are the two that put 0 in the denominator. Okay. Let's come across over here to pi. I'm gonna jump way. I'm sorry. What? Not pi. We're not doing pi yet. Let's come all the way over here to 180. What? We've collapsed the triangle down to nothing again vertically on this side, right? This is the other x-axis. What's the ordered pair there? If I go from the center straight left 1 unit, it's -1, 0 now, isn't it? So this is the other angle, 180, where I've collapsed the triangle's height down to nothing. To nothing, the height down to nothing. We collapse the height of it down to nothing. Height down to nothing. Oh yeah. Now, when you collapse the height down to nothing, what value is 0? If the height is 0, which trig function is 0 if the height is 0? Sine, way, height, okay? So what's cosine of 0? Yeah, what's cosine of 0? I meant to ask that. What's cosine of 0? 1. What's cosine of 180? Cosine is x. What's cosine of 180? Cosine is x. Stared. -1. Yeah. What's cosine of 180? -1. What's cosine of 0? 1. But what's cosine of 180? -1. So that's when the width is at its maximum on the x-axis. Okay, 1 or -1. But what's the sine of 180? 0. What's the sine of 0? 0. Yeah. What's the sine of 360? 0. And what's the sine of 180? 0. Yeah, the height is gone. Oops. Okay. What would the secant of 180 be? Not quite. -1, because guess what the reciprocal of -1 is? -1. Yeah, 1 and -1 are their own reciprocals. So what's secant of 180? -1. Okay, good. What would the tangent of 180 be? Zero, because tangents fly over x. What's 0 divided by -1? 0. Okay, and now the other two. What's cotangent of 180? D and E. What's cosecant of 180? D and E, right? Cotangent would be -1 over 0, which is tan divided by 0, D and E. Cosecant would be the reciprocal of 0, which is still D and E. The reciprocal of 0 is not 0. Okay. Some people say, yeah, but if you make your hand like a 0 and then you flip it, it still look like a 0. Yeah, well, you're not. That's not in the math class. That's when you're in a donut shop. Okay, right? The reciprocal of 0 is what? D and E, because it's some type of infinity. Okay, so those are the two quadrantal angles that land on the x-axis. Let's look at this one up here. This is 90 degrees, and what's the ordered pair there? From the origin, I don't go left or right, so it's 0, but I go straight up to 1, 0, 1. So guess what we've done now? We've collapsed the triangle's width down to nothing, the width down to nothing, the width down to nothing. So if we collapse the width down to nothing, which trig function would be 0? Which one measures the width? Cosine. Good. And now the sine is at its maximum. Okay. So what is the cosine of 90? 0. What's sine of 90? 1. What's secant of 90? D and E. So reciprocal is 0. What is cosecant of 90? 1. Good. What is cotangent of 90? 0, because it's 0 divided by 1, x divided by y. And what is tangent of 90 degrees? D and E, because it's 1 divided by 0. Okay. Now, let's go to the last one. I'm down at the y-axis again. This is 270 degrees, and the ordered pair is 0, -1. Okay. What is cosine of 270? 0. Good. What is secant of 270? D and E. What is sine of 270? -1. What is cosecant of 270? -1. What is cotangent of 270? 0. And what is tangent of 270? Does not exist. Boom. There it is. There's the unit circle in degrees. Tomorrow, we're going to come back and we're going to add radians to every one of those. And we're actually not going to be using the degrees anymore. We're going to learn all of those ratios with radians. And it's actually going to be easier. Okay. And you're like, oh man, so why do we do it in degrees? Well, it's still going to work, right? I can still ask you, what's tangent of 225 degrees? What is it? Look at this unit circle now. Just rapid random fire, right? Like what's happening in Ukraine right now. Take cover. Those guys are fighters. I applaud them. What is tangent of 225? 1. Good. What is secant of 210? -2 squared root of 3 over 3. Good. What is tangent? What is tangent of 300? negative square root of 3. Okay, got it? So that's how we're going to use it, except you're going to memorize it in terms of radians. And we're going to start quizzing where I give you 10 random trig functions with random angles and radians. I give you 10 minutes, and then we'll quiz the next day. I give you 8 minutes, and then we quiz the next day. You do 10 and 6, and then we do the next day, and you do 10 and 3, and then we quiz the next day, and you do 10 and 2, and then we quiz the next day, and you do 10 in 1 minute, and then I quiz you the next day, and you do 10 in 10 seconds, and then we quiz the next day, and I give you 10 in a half a second, and then I give you 10 in a nanosecond, and pretty soon everybody's failing, and I don't know why, because you should be really good by that point, right? Yeah. All right. Fantastic lesson today. Y'all have a great rest of your Thursday. Remember, it's cold cuts day. And if you're Mahatma Gandhi on this day, you stay away from them. Yep, stay away from them.